Alright guys, so in this video we're going to cover more examples of rewriting using the radicals and rational exponents. So this first example asks to rewrite the following expression using radicals. So you can see right now we have a rational exponent, right? Remember, rational is just a fancy word for fraction. Okay, so right now it's in a fraction exponent, and we want to rewrite it to write it as a radical. So remember that the numerator of that fraction is the power for whatever's in parentheses, and then the denominator is the index for the radical. So all of this 6d, which is to the power of 1, has the index of 4. So in other words, if you have a power of 1, obviously that's not going to change it. So it's just the fourth root of 6d. Now, if the fourth root of 6 would be able to be simplified, right, then you would. But 6 is just 3 times 2, so there aren't any 4 base copies that could come out from that radical, so you'd leave it just like that, and that is your answer. Now notice again that both 6 and d were in parentheses and had that power, so that's why both of them are under the radical. Now number 2, we actually have 4 parts for number 2, a, b, c, and d, and what we're doing here is the reverse. We're given something as a radical, and we have to write it with fraction exponents, with rational exponents. So what I would suggest is first writing out if you're able to simplify on the inside, then simplify. This x plus 2 to the power of 4 would just be a really long polynomial, so I'm just going to leave it like that. And then that whole thing that's in parentheses has a power of 4, and then the index is 3, so the denominator will be 3. And that's writing it as a fraction exponent. Okay, so moving on to part B, we have multiple things going on here. So first, let's just go ahead and write each of those. So this is y to the power of 1, and the index is 6. And then we have y to the power of 1, and the index is 3. And then we have y to the power of 2, and the index is 5. Remember, the index is always the denominator of the fraction exponent. So because all of these bases are y, and these are all multiplying together, you can actually add the exponents, right? So we will need to combine and add, and I'll just do this work here on the side, 1/6 plus 1/3 plus 2/5. Now, in order to add these fractions, you do need common denominators, right? So you could find the least common multiple, which would be 30, right? Multiply this fraction by 5, that would make the denominator 30. Multiply this fraction by 10, that would make the denominator 30. Multiply this fraction by 6, and that would make this denominator 30. Alternatively, I pulled up my calculator because you could just use your calculator. Remember, this is the fraction button. So we have 1/6 plus 1/3 plus 2/5. And of course, we should be able to do this fraction operation by hand, but we have a calculator, so why not use it? So all of these added together are 9/10. So this will end up being y to the power of 9/10. And again, I'm leaving this with fraction exponents because that's what they asked for. Rewrite it with fraction exponents. Moving on to part C. We have the cube root of all of this. Now, there's a lot going on the inside, so I'm actually first, before I write it with a fraction exponent, I'm going to simplify what's on the inside first. So I have the cube root of, and then I have in the numerator 8x to the power of 7. If you look in the denominator, this whole denominator has the power of -1, and remember that will change the side of the fraction that it's on. So I'm going to go ahead and bring that to the numerator, 27y to the power of 5, and I'm going to put that to the positive power of 1. So right now we have the cube root of 8 times x to the power of 7 times 27 to the power of 1 times y to the power of 5 times 1, which of course would just be y to the power of 5. So now let's go ahead and multiply. 8 times 27 is 216. So we have the cube root of 216 times x to the power of 7 times y to the power of 5. Now that everything is simplified on the inside, I'm going to go ahead and distribute that radical. Now the cube root of 216, let's see if that's a perfect cube. So the cube root of 216 equals 6. And then x to the power of 7 over 3, because the index is 3, and y to the power of 5 over 3. Now remember, you can leave it like this, or you can take out any full copies. So 7 over 3 would be 2 and 1/3, right? And 5 over 3 is 1 and 2/3. So we end up with 6, and then x is the one that was 2 and 1/3. So we have 2 full copies of x, and then 1/3 copy of x. And then we have the 5/3 was for the y, so we have 1 full copy of y, and then 2/3 copy of y remaining. And remember, you will need to do this where you split up the full copies when you're writing it as a radical. So if it was just simplifying this and keeping it with a radical, then you would have to do this final step of splitting it up, and then it would be 6x squared y, and then the cube root, because both of these are index of 3, of x to the power of 1, y to the power of 2. And that's how it would be if it was asking me to write it in radical form. Now, it didn't ask me to write it in radical form, so I'm not going to keep that there, but just as an added, explanation. Okay, moving right along to part D. So part D is actually looks complex because you have multiple radicals, right? You have a square root, right? The index is imaginary, so but we know it's 2, right, for the square root. And then we have a cube root. So we have the square root of all of this and the cube root of all of this. So just like here, okay, whenever you have multiple things going on, you want to work from the inside out. Simplify the inside first and then apply the next one. So let's go ahead and first write the cube root. So we have what's inside, which is y plus 1 to the power of 4, and that was an index of 3, so that will go over 3. Then I have the square root of that. So I have the y plus 1, which was 4 divided by 3. And then we have an index of 2, right? So it's all of this with an index of 2, so 1/2. Or I think it's quicker to just, if you have another index, then you can go ahead and multiply to the denominator, because that's where that index goes anyway. So 3 times 2 would be 6. So the final step is just simplifying that fraction, right? 4 over 6 can be simplified to 2/3, so our final answer will be y plus 1 to the power of 2/3. All right. Now go ahead and pause this video now and try these next problems on your own. All right, so let's start from the top, number 3. So we have rewriting using radicals, right? So we're going to go ahead and keep the power, which is the numerator, and then the denominator is our index. So it's the cube root of 10y to the power of 2. Now, because that is a power there, I have to simplify that on the inside. So I will distribute that power, 10 to the power of 2, y to the power of 2. Now 10 to the power of 2 is 10 times 10, which is 100. So I have the cube root of 100y squared. Now, can the cube root of 100 be simplified? Well, let's find out. Let's go ahead and prime factorize 100. So 100 can be split up into 2 times 50. 50 can be split up into 2 times 25. And 25 can be split up into 5 times 5. Now, none of this can be split up any further. So 100 is 2 times 2 times 5 times 5. Now, in order for this to simplify, right, I would have to have 3 full copies, because this is the cube root, 3 full copies of any of these prime bases in order for that number to come out. So since I don't have 3 full copies of any of the bases, I have 2 copies of 2 and I have 2 copies of 5, then this will stay like that, and that's as simple as we can get, okay? And that is our final answer for number 3. Number 4, we are rewriting the following expressions, and we're going to use rational exponents. So we need fraction exponents on this one. And we have 3 parts, A, B, and C. Okay, starting from the part A, let's go ahead and put that index in the denominator, right? So this would be the 2x minus 3. That power of 3 stays, and then the index, which is 4, is the denominator of that exponent. And that's it. There's nothing to simplify in here. So we're done. Okay, moving right along from there, for part B, we have multiple radicals, right? We have the 4th root, and then we have the square root of all of this. So again, let's just do it by steps. So we have the 4th root of the x minus 1 to the power of 5, and that power of 5 will have a denominator of 2 because we had the square root there. And then now we have the 4th root. So in the power, the denominator, which was 2, is now going to be 2 times 4, because we have another index of 4 that will go in that denominator as well. So 2 times 4 is 8. And we can't simplify that fraction, can't simplify inside, we're done. All right, last one, part C. All right, now part C, there's a lot going on. We have the square root of all of this in the inside. Remember, if you have a lot going on, you want to simplify the inside first. It's just going to make it a little bit easier. So I'm going to go ahead and move. Actually, everything will go in the numerator. So the numerator for x11 will stay. And then all of this is in parentheses to the power of -2. So the whole thing will move to the numerator with the power of +2. Then I need to simplify this further, so I'm going to distribute that power of 2 to both of these. So I end up with the square root of 4x to the power of 11, and then 256 to the power of 11. Wait, is it 11? No, power of 2. 256 to the power of 2 is 65,536. And y to the power of 8 to the power of 2 will be y to the power of 8 times 2, which is y to the power of 16. All right. Then 4 times that number we can multiply together. So times 4, 262,144. X to the power of 11, y to the power of 16. Now we're ready. Well, let me not forget the square root. Now we're ready to write it as a rational exponent. Remember, that's the goal in all of these. Of course, simplify, but then just changing it to writing it as a rational exponent instead of writing it as a radical. So let's see if the square root of this gives me a nice whole number. So I'm going to take the square root, and then instead of having to write that number in, I'm just going to hit second, and then the negative symbol will put my answer from the previous computation, and it did happen to be a nice whole number, so that's 512. And then x to the power of 11, this is the square root, so the denominator of that fraction would be 2, and then y to the power of 16 over 2 as well, because that also had the square root above it. So we can obviously simplify 16 over 2 is 8. So we have 512 x to the power of 11 over 2, y to the power of 8. Now you can leave this like this, or you can split up, right? Because 11 over 2 is an improper fraction. 11 over 2 is 5 and 1/2. So we have 5 full copies of x. So we could write it as 512 x to the power of 5, x to the power of 1/2, y to the power of 8, because there were 5 full copies of x, and then we had the 1/2 that was remaining. All right, so let's try a couple of challenge questions, okay? So both of these are challenge questions because you have to kind of think a little bit more and outside the box. So number one says, given that y is a negative integer, so remember that an integer is just a whole number. So we're talking about a positive or negative whole number. So here specifically, they're talking about negative whole number. So we're looking at a negative integer. Which of the following statements is always true? Always true. So let's just, right now it's very arbitrary. Let's go ahead and pick a negative integer. The easiest one will be -1, right? This is the technically the largest negative number, right? So negative integer. So let's just try with -1, and what I'll do is I'll just check each of one of these statements, right? So let's see. 5 times -1 to the power of -2, is that less than 4 times -1 to the power of -1? Well, let's see. Changing this to the denominator, right? It will be 5 over -1 to the power of 2. And then changing this to the denominator, this would be 4 over -1 to the power of 1. So -1 to the power of 2 would be +1. So this would be +5. And we're saying that that is less than 4 divided by -1, which would be -4. Is that true? No. So A is not correct. Let's try B next. Okay. This one says that 5 times -1 to the power of -1 is less than 4 times -1 to the power of -1. Okay, well, let's see. Switching that to the denominator, right, will be 5 over -1 to the power of +1, and then 4 over -1 to the power of +1. So here we have 5 divided by -1, which is -5, and 4 divided by -1, which is -4. Okay, so this is actually true, right? -5 is less than -4. So it looks like maybe B is correct. Let's just check C and D to make sure that this one is the only one that is true, because it might be that it works for -1, but it might not work for, let's say, -50 or -100. So let's just go ahead and check C and D as well. If both of those are also false, then we know by default B is the only true one when we checked this one negative integer. So of course, all of the other ones would be the only chance that it would all be true. So we have y, which again, we're just saying we're checking with -1 over 4. Is that greater than -5 times -1 to the power of -1? Okay, now -1/4 is just -0.25, right? And the -1 to the power of -1, because the power is negative, I will bring that to the denominator and write it with a positive power. So we have -5 divided by -1, which is 5. So is -0.25 bigger than 5? No. Negative number is smaller than a positive number. So that one is also incorrect. Let's check D last. So on D, we have 4 times -1 to the power of -1 is greater than 5 times -1, all to the power of -1. So all of this will change the sign and go to the denominator, and then have a power of +1. So we have 5 times -1, which is -5, and that has a power of 1. -5 to the power of 1 would just be -5. So we have -1/5, which is -0.25. No, -0.2, sorry, -0.2. So on the left, we have 4 times -1 to the power of -1. And actually, we had already done that right here, right? That would bring the -1 to the power of -1 to the bottom as -1 to the power of +1. So that would just be -1. 4 divided by -1 is -4. Is -4 greater than -0.2? No. The bigger the negative, the smaller it actually is. So all of those were false. The only one when we checked a negative integer, we checked it with -1, but that is a negative integer. The only one that was true was B. Okay, let's move on to number 2. So it says, consider the following equation with radicals and rational exponents. So we have a mix of the two. And it says, what is the quotient of B and A? So what is the result after division of B and A? Now, I don't know what B and A are, so of course I will need to find those first before I can divide them. So I don't like that there's a mix of radical and rational exponents. So that's the first thing. I will write them all with rational exponents. That's going to make it easier. Okay, so I'm going to change the 11 to the power of b, and that has the index of a, so that will be in the denominator. And then we have 11 to the power of 9 over 4, and then here we have 11 to the power of 3, and then this is the square root, so that denominator will be 2. Okay, so I need to find b over a, right? I need to figure out what are these two divided together. I need to find b, I need to find a, and then I need to divide them. So I need to isolate this term. And all of these bases are 11, so I can actually add these two together, right? So that's what I will do first. I'm going to go ahead and add 9 over 4 plus 3 over 2. $15 over 4. Okay, next I need to get rid of this right here, the 11 to the power 19 over 4. So because that is multiplying this, I'm just going to go ahead and divide 11 to the power 19 over 4, which will cancel that. And of course, whatever I do to one side of the equation, I have to do to the other to balance it out. So I have 11 to the power of b over a equals 11 to the power of 15 over 4 divided by 11 to the power 19 over 4. Now, when dividing, same base, what do we do with the exponents? Subtract them. So I'm going to do 15 over 4 minus 19 over 4. I don't even need a calculator for that. That's negative 4 over 4, which is negative 1, okay? But I'm going to leave it as negative 4 over 4 because what's b and what's a? So b is negative 4 and a is positive 4. So what is the quotient of b and a? Negative 4 divided by 4 is negative 1. And that is the answer for number 2. All right, so go ahead and pause this video now and try number 3 on your own. Okay, so with number 3, all right, they ask you what is the value of this if x is 81? Now this is actually quite an easy question if you do it step by step, okay? So let's go ahead and first write in what we're going to substitute for x, which is 81. So I have 5 times 81 to the power of 1/2 plus the square root of 81 to the power of 0 plus 81 to the power of 1/4. Okay, so let's go ahead and simplify first our exponents, right? So 81 to the power of 1/2, that's the square root of 81, which is 9. So I have 5 times 9. And then I have 81 to the power of 0. Anything to the power of 0 is 1. Plus 81 to the power of 1/4. So that's the 4th root of 81, which I believe is 3. But I'll also show you on the calculator, you could do 81 to the power, and you can even in the power put a fraction, 1 over 4, and it will give you that it's 3. Or you can know that it's the 4th root and do 4 index, 4th root of 81, and it will give you 3 as well. So you could do it either way. All right, moving on, let's go ahead and simplify each term. So I could take the square root of 1, which is 1, and I could do 5 times 9, which is 45. Okay, then I can add all of those together. 45 plus 1 is 46, plus 3 is 49. So this is the square root of 49, which is 7. All right, so hopefully those more examples were helpful, and I will see you guys in the next video. Bye!